fantastic day, because I am for sure. Because today we are learning about internal combustion engines. And not a lot of people know what this is. Because when I say the words internal combustion engines to your face, you're probably like, what's that? Well, today we're going to learn all about them. And if you're enjoying the content on this channel, smash that like button, smash that subscribe button, and hit that notification bell to become a super subscriber today. Let's get into the video. Internal combustion engines. So, first off, let's kick it off with what we're going to cover today. And we have 5 sections today, including the conclusion. So first of all, we need to know about the history of the internal combustion engines. Then we're going to move on to the parts of the internal combustion engine. Then we're going to move on to the 2 types of internal combustion engines. And I'm going to explain the entire process of how the internal combustion engine functions. Then we're going to finally go on to the how internal engines can be used in the future and wrap it up with a conclusion. So anyway, what are internal combustion engines and how are they used? Well, in simple terms, internal combustion engines are the most common heat engines for vehicles. So let's go on to the history and learn how the internal combustion came to be. In 1864, Nicholas Otto created the first 4-part engine. In 1872, Nicholas Otto created the fully automated internal combustion engine. Now, when you think of the internal combustion engine, you probably think of something that was created maybe 1950 or something way more closer to 2020. But that's not the case. It was actually created way back in 1872, and it has been carried all along and is still being used in 2020. In the 1800s, the internal combustion engine were used only for boats and a few other machines before vehicles started using it. Now, let's go on to the parts of the internal combustion engines. So, the parts of the internal combustion engine are similar to what's going to be your vocabulary words, because these are the things that you need to know as we go on and talk about the process of the internal combustion engine. So first off, we have the piston, and the piston is used to convert gas pressure into mechanical force. The piston is basically taking all of the fuel-air mixture that is sucked into the cylinder and pressuring it all the way to the top and making it mechanical force. Then we have the inlet valve, a valve that is opened at the specific time so that it can catch fuel air inside the cylinder. We were talking about fuel air when I introduced the piston, and basically the fuel air is all of the fuel and air mixture that is sucked into the internal combustion engine, whereas the piston will go and pressure it, causing a spark which is needed to function the car or the vehicle. Then we have the exhaust valve, which is included in the last step, where all excess exhaust leaves the machine. This is a long process for the internal combustion engine to process, but there's always exhaust that comes in. So the exhaust valve is the last step where all of the exhaust leaves the machine and lets the car or vehicle function. Then obviously we have the crank, which is used to operate the whole machine and keeps repeating itself. Now let's hit a fun fact for the road. Rudolf Diesel's first engine ran on peanut oil. Sounds very crazy, but if you look at the picture on the left, you can notice that it's not exactly the most complex design, but it definitely was advanced and carried through, and now obviously it's not on peanut oil, but it has been evolved as it came to where we are today. Now, the most important part probably, we're going to move on to the 2 types of internal combustion engines. there's a 4-stroke engine and a 2-stroke engine. And you're probably wondering, why are there two different engines when you can just use one? Well, both of the processes are very similar, but the 2-stroke engine is used for vehicles or any machine that is quite small and can't handle the heavy weight that a 4-stroke engine has to offer. Whereas the 4-stroke engine will be used for cars and big vehicles. The 2-stroke engine will most likely be used for stuff like lawnmowers and other stuff. So I'm going to explain the whole process and how they work, making the car or vehicle function. So let's start off with the 4-stroke engine, and this process has 4 steps. Similarly, the 2-stroke engine has 2-step process. So the 4 steps in the 4-stroke engine are intake, compression, power, and then exhaust. And I'm going to explain each one so that you understand what's happening inside the internal combustion engine. So let's start off with intake. The intake is when all of the fuel-air mixture is sucked into the cylinder when the inlet valve is opened. The crankshaft is pulled, and that's when the inlet valve will open and allow all of that fuel-air mixture that's needed to be put into the cylinder. This is one of the most important steps in the process. Then we have number 2, compression. Compression is where the piston is putting a lot of pressure as it's going up and putting pressure on the fuel-air mixture. And as it goes all the way to the top, it's going to make a big spark. And this is what is used to function the internal combustion engine. And the spark is when the piston reaches its final point at the very top. And this is also the 3rd step, power. Then finally, we have number 4, exhaust. And exhaust is where the exhaust valve is opened and all the excess exhaust is emptied through and releases from the car or vehicle. Now, let's go on to the 2-stroke engine. The first one is upstroke. Then we have downstroke. So let's start off with upstroke. Upstroke is very, very similar to the intake within the 4-stroke engine. The upstroke is when the fuel air is sucked into the cylinder and the piston starts to move up, pressuring the fuel air, and then it allows a spark to happen at the end. And this is basically the same thing that's happening in the first 3 steps of the 4-stroke engine. But what's different about this one is that when the piston moves up, fuel air mixture is put below the piston. So not all of the fuel air is pressured to become force. Instead, it stays inside the machine, and possibly if there's any extra exhaust can be exited through the exhaust valve. Then we have downstroke. And the downstroke is when the ignited fuel pushes the piston down and it turns the crankshaft. The transfer port is uncovered because the piston moves, forcing the fuel to go to the top of the cylinder, and then it allows the process to repeat all over again. Now, let's move on to how we can use it in the future. And this one is interesting because the thing is, we can't. In the future, the internal combustion engine is most likely not to be used because electric cars are taking the car industry away, and electric cars have no need to use an internal combustion engine because it runs on electricity. So most likely in the future, we will not need to be using internal combustion engines. So now, to wrap it all up, let's finish with the conclusion. Internal combustion engines are amazing, and we cannot use vehicles without this intricate system. Although many people think that they are not a great invention, And probably if you didn't watch this video before, and if I just said internal combustion engine to you, you probably wouldn't know what it was. But still, it will definitely be noted as one of the best inventions of all time, and it has definitely helped us in so many ways. Alrighty everybody, this is the end of the video. I hope you enjoyed watching it, and hopefully you learned a little bit about internal combustion engines. As always be curious, listen, learn, and leap forward. And I encourage you to do your own research, learn more about internal combustion engines, and become expertise in that topic. I'll see you in the next one. Bye now.